All right, welcome to Multiplying and Dividing Radical Expressions, Part 1. Now what we're going to be doing here, and start off with a little example, is we're going to try and multiply these things together. So in my first example I got 2 root 6, and I multiply that by 5 root 3, and show you how we would deal with that. Well, first of all, everything here is technically multiplied together, so the order doesn't actually matter. I mean, here's really what you got. You got 2 times root 6 times 5 times root 3. And anytime you multiply stuff together, you can switch the order. It doesn't really matter. So I can think of this as 2 times that 5. Kind of just switch these two guys around, actually. So I would have a 10. And then my 2 radicals, I'm going to throw them under one roof and throw them together as 6 times 3 under one square root. So here's what I got. 10 times root 18. So that was pretty easy. So far so good, but you would not want to stop. As long as you can still break this guy down, you should do so. So you would be expected now to recognize that you can take root 18 and think of it as root 9 times root 2. And so we end up with a 10 times 3 times root 2. So our final answer on this one would be 30 times the square root of 2. And now we're at the end of the road on that one. Nothing more we can do to simplify it. Okay, so that's our starter example. I'm just going to clear the screen here and do a little bit more complicated example now. Okay, so what if you got something, say, like root x plus 3 in brackets all squared? How do we deal with that? Well, my recommendation is that you write out exactly what you have that you're squaring, and then you can really see what you're going to do here. Most mistakes happen when people try to do too many shortcuts. So I'm going to take the time and write all this out, and I go, oh, I see what I've got to do here. I've got to distribute and multiply everything together. In other words, I got to go root x times root x. Okay, well, root x times root x, that's just going to be x. Okay, now just so we're clear on that, it's kind of like if you took root 2 and you multiplied it by root 2. You'd end up with root 4, which is just 2. So it's kind of like if you see, root 7 times root 7, I don't need to keep going. I know I'm going to end up with 7. Okay, so here I've got root x times root x. So I know that's just going to be x. All right, let's just put a line here so we don't get mixed up with that. Okay, then I've got to go root x times positive 3. So that's positive 3 root x. Okay, now I carry on with positive 3 times root x. So positive 3 times root x. And finally, I've got 3 times 3, which is 9. And so what have I got here as far as like terms? Well, not too much. I've got x. These are like radicals, so at least those two combine, and I could say I have 6 of these root x's, and then plus 9. Okay, and that's as far as we can take this. It doesn't get any easier as far as simplifying or combining like terms. So that's the end of the road on that one. Okay, on to our next example. Okay, next one is a little bit more complicated radicals. So we're going to try and multiply out this stuff. A cube root of x and plus a cube root of y. Okay, you're going to multiply that by cube root of an x squared minus the cube root of y squared. So, okay, quite a bit of messy stuff here. Now, in the big picture, I still have to do this. I got to multiply each term with every other term here. So, cube root of x times the cube root of x squared. Well, at least they're both cube roots. So what I have is the cube root of, and I got an x times an x squared. So that's actually x cubed. I think that's going to just turn into x, but we'll do that at the next step. Okay, now I got to go this guy times this guy. So what do we got there? I see it's going to be negative, and they're both cube roots. Okay, so put them together under one radical, and I got an x times a y squared in there. So there's not much I can do about that. Okay, now I'm going to move on to this one here. Now this is positive, and they're cube roots as well. And I have x squared and a y. I always like to keep them in alphabetical order. It's less likely to miss stuff that way. And then my last one here is going to be negative, and it is a cube root of y cubed. Okay, so let's see what we can do to simplify this, if much of anything. Pretty much all I can do is recognize that the cube root of something cubed is that x. These two do not go together, so I have to leave these guys separate. That's kind of annoying, but what can you do? Okay, so there's that one, and there's this one. So we're just writing it all out, x squared and a y. And then the last one is just minus y. And that's all I can do. Nothing much more you can do. All right, we're on to our last example. Okay, so this one here, we're going to have some radical stuff thrown at you. So we're going to take the square root of x to the fifth, and we're going to multiply that by the cube root of x. Now, the difficult thing here is this one's a square root, and this one's a cube root. So you can't just kind of sweep them together under one radical. I mean, what's it supposed to be? A square root or a cube root? Or you know, what do you do? So don't get drawn in. This is an easy thing to get kind of fooled and make up your own rules. So you got to fight it and say, no, here's what I'm going to do. I'm going to write these as powers. Instead of writing this as the square root of x to the fifth, I'm going to write it as x to the 5 halves. Okay, and I'm going to multiply that by x to the, well, there's no exponent here, just the invisible 1, so this would be 1/3. Okay, so now I can deal with this. Now I can look at these and say I have powers with the same base, and when we multiply powers with the same base together, the rule is you add the exponents. So this is what I'm supposed to do. Now, when I add fractions, I need a common denominator. So let's do that over here. Let's add these together. I have 5 halves plus 1/3. My common denominator, I think, is going to be 6. So I'm going to multiply the top and bottoms by 3, and over here the top and bottoms by 2. So I'm going to have, over 6, I'm going to have 5 times 3 is 15, plus 2. All right, so there's my new fraction. This is x to the 17/6. All right, so that looks pretty messy. Or if we want to write it as a radical, we could write it as the 6th root of x to the 17. Now, that's pretty good, but you shouldn't leave it this way because this thing can be worked down a little bit more. Let me just show you how we're going to work this thing down. Okay, I'm going to break up this x to the 17. I'm going to go x to the 6 times another x to the 6 times, now I can't get another x to the 6 out of there because that's already 6 plus 6 is 12, so I only have 5 more x's. Okay, so here's kind of what here's my thinking here, all right? If I split these now, I got this guy times this guy times this guy. Just barely squeeze them in there. X to the 5th. All right, so here's what I got. The 6th root of x to the 6th is just x. So I got x times another x times the 6th root of x to the 5th. So here's my final answer. Took a lot of work to get there, but we got x squared out in front and the 6th root of x to the 5th. And that is the end of the road on this one. And wow, that was a fair bit of work, I'd have to say. Okay, let's stop there. That was enough. I am exhausted, and I am going to stop.